Hello students, welcome you all on YourPedia panel. So my dear students, is it audible, visible? Please say yes. Manikanta, Professor. Yeah, is it audible my dear? Oh, great. So hello my dear students, first of all, good luck for you. So now in this series or video, we are going to solve this sample paper, which is you can may find the same pattern, same type of problems in your exam. So day after tomorrow you have the exam. So my dear students, in this test we are trying to cover the concept of each and every topic. As you know, all the questions are simple, fine, but they are trying to, but here whatever the question we are including, they are very simple in nature, and but the main point is they are going to cover the concept. So my dear students, you have to keep in mind in the exam that first of all, as you know, almost 40 or above 40 questions are of the aptitude. So my dear students, don't waste time on the most of the time. Like if you just you have to solve the aptitude part as fast as possible. Keep in mind, this is the suggestion or you can say advice from my team. Fine. Next, my dear students, try to go through the paper one or two times. Fine, don't stuck on a simple question. Fine, sometimes what happen, whatever you are trying to solve due to some silly mistake, the options are not matched. So don't do these type of silly mistakes. Fine, my dear students. So we are trying to cover almost 78 problems which are technical in nature. As you know, the paper of NIC pattern is 78 question from the technical part and 42 question from the aptitude part. But here in this paper, we are not trying to cover the aptitudes, as we know that you are very good in aptitude. So we are trying to cover 78 questions from each and every subject. So stay with us at the end. And one more thing, one announcement from the YourPedia team is today at 5 p.m. the mock test, which is free. The link of the that mock test is in the description. You can at 5 you can start your mock. This is again a practice session, so you can attempt that mock, and you can download the solution of that mock plus 78 question here. So 120 plus 78, almost 200 problems, my dear students. So in these 200 problems, you are going to cover each and every topic. Fine, my dear students. So start with the first problem. So here the first problem.
Okay, thank you, sir. Hello, everyone. So, just a second. Yes. Okay, so the problem is let S and T be two languages over some alphabets A and B, represented respectively by regular expressions. So, two regular expressions have been given to you, and it is saying whether what is the relation between the regular expressions. So, what we are trying to do here is, if any language, if let's say this language has one string extra, so this means T will be the bigger set. If this language has one string, at least one string extra, S will be the bigger set. If both are equal, then we'll say equal, and if there is no relation, then we cannot say anything. So let's try to see this first. A star plus B star whole star. Now, as we know from the property, let me write down the property first. So R plus S star is always equal to R star plus S whole star is always equal to R plus S star whole star is always equal to R star plus S star whole star. So what it is trying to say is, even if you have R star here, it will only generate number of R's. Let's say you generate 10 R's from this. Same you can do from this side also, and same you can do from this side also. So it does not matter if you have two regular expressions and you add it and then you take the clean closure of it, it will be equal to the clean closure of first plus S over whole clean closure and so on. So the correct option will be option C. So let's move on to the next question. So this is the solution. Yes. So the next question is, read it down. So the next question is, which of the following defines a regular expression that describes a set of strings strings of zeros and other in which every zero is followed by at least two consecutive ones. So every zero is followed by at least two consecutive ones. Now we will use elimination method here. So what we will do here is, if you see here, you have 0 1 1 star. So in this, if I use this star as 1 and everything else star value is 0, you can make the minimum string possible will be 0 1. So 0 is not followed by at least two consecutive ones. So this will not be the case. Here you will see, whenever you take this 0, you have to take two ones with it, and here also whenever you take 0, you can take two ones with it. After that there can be many ones, but it is saying at least two consecutive ones. So every time it will have two consecutive ones. So it will be B and C. So correct option will be option C. Yes. Now the next is, okay, so for it is for computer networks.
So my dear students, now tell me fast, what is the right answer for option C? Match the following list 1 with list 2. We have data link layer. One side we have the name of the layer, and other side what type of data unit we are going to use on these layers. Now tell me, my dear students, fast, what is the correct answer for question number 3? Here Tejasvi Devanand saying A is data link layer, frame, network layer, packet, and transport layer segment. A, Lucky, very good. Partha, very good. So the right answer is A. Why? Because if I talk about the data link layer, at data link layer, we are going to use the data unit as frame. And as you know that the main functionality of data link layer is framing, error control, access control, and flow control. Always keep in mind, my dear students, these are the main 4 functionality of data link layer. What are these? First is framing, the next is flow control, error control, access control. Keep in mind. So at data link layer, frame, the data unit we are going to use is frame. At network layer, packet. As we know, at network layer, the main functionality is the routing, the forward the packet. Fine. And next one is at the transport layer, we are going to use segment. So A, P, B, Q, C, R. So right answer is A, P, B, Q, C, R. A is the right option. Very good, my dear students. Next.
Okay, so the next is which of the following is the counter positive of this statement given to you? So counter positive we can find very easily. If P implies Q, then counter positive implies that counter positive says that Q negation will be equal to P negation. Let's say Q and P are different here. So this is the counter positive. So in order to do the counter positive, just take the right side. So R bar dot S negation implication PQ whole bar. So if you open it, it will say R plus S bar implication P bar plus Q bar. So it is option C. Yes, option C. Counter positive we have to see. Next is, okay, so it is a question of cache memory. So cache memory is a 2-level memory of has average access time. So total average access time has been given to you with cache and memory access time of this, and it is saying what will be the hit ratio. Now what we can do is, so whenever we are going to access memory, there will be cache here. If it is present in the cache, we will take it. If it is not present in the cache, we will go to the main memory and then we will access it. So let's say hit ratio is X. So whenever there is a hit in the cache, we will just be utilizing cache time, which is 10, I guess, 20. Yes. And after that, whenever there is a miss, so 1 minus X. If X is the hit ratio, miss ratio will be 1 minus X. So in this case, we will be utilizing 20 plus 150. So 20 plus 150 is 170, which should be equal to 30 as given in the average access time. So it will be equal to 30 and 170 will come here. So it will be minus 140, and this side we will have minus 150X. So x will be equal to 14 by 15. If you calculate it, it will come out to be B, 0.093 or 93%.
So next, my dear students, the given problem is if n numbers or n elements are inserted into a binary search tree. Keep in mind the question is related to binary search tree. Always, then which of the following traversal outputs the number in sorted order? So please keep in mind these two terms are very important. The first one is binary search tree and the next one is in sorted order. Now tell me what is the right answer? Pre-order, in-order, post-order or BFS? Fast. And when my simple suggestion, my dear students, keep in mind you have to like solve the problems, like hardly you have to take 30 seconds for each and every problem, right? Because some of the problems are big in nature, large in nature, so you have to solve like the previous problem. So keep in mind whatever the simple problem, just try to read continuously and you have to mark as early as possible. Fine. So my dear students, we know that if I talk about the BST, the in order of BST is always sorted in nature. Fine, keep in mind this point. The BST is always sorted in nature. And one more problem is sometimes what happens, they may ask you, they may give you either the pre-order or they may give you the post-order. Fine. So in that case, they may ask you what is the resultant BST. So what you have to do, you have to consider whatever they give and always write this sequence in sorted order to make the in order. And we know that in order is always sorted in nature. Fine, my dear students. So just by take the pre-order, and in the case of BST, in order is sorted. In this way, you have to construct the unique BST. Fine. So the right answer is B. Very good, my dear students. Next. Next one. Yes, do it fast.
Okay, the next is which of the following graphs is not planar? So what we do in the case of planar is that the lines should not intersect in one plane. So we'll try to make these lines not intersect in a plane. If we can do that, then it is not planar. So if I see this, if I draw this as like this, so G4 will be planar. If I see this, now in these edges, see which edge is cutting the most number of edges. So this edge is cutting two edges. This edge is cutting one. This edge is also cutting two. This edge is also cutting two. So first I will sort this. Then I can do this, and then let it be what it is. Then it is a planar graph. No two edges are intersecting in a plane. This is quite easy. So what we will do here is take this and take this, and rest will be same. So in this graph you cannot remove the edges in such a way that they are not cutting each other. So option B, which is G3 graph, is not planar. Next question is,
So my dear student, next problem related to the data structure. Here the stack and queue concept are there. So here the first 5 item P, Q, R, S, T, we have to push into the stack one after the another starting from the P. It means what you have to do, you have to insert these elements as it is into the stack. Now tell me the right answer. The stack is popped 4 times. You have to pop out 4 elements and each element is then inserted into the queue. So whenever you have to pop the items, then you have to insert it into the queue. Then 2 elements you have to delete from the queue, and again you have to insert those elements into the stack. And now tell me which item we have to pop from the stack. Do it fast, my dear students. Please write question number A, P, Q, R or S. What is the right answer? P, Q, R or S? Yes, do it fast, my dear students. Yes. Hardly it's a, your Partha is saying S, Devanand is D is SS. Okay, very good, very good. Yes, what about others? Lucky, Devanand, Simran? Very good, my dear students. If we go with the problem, see, my dear students, what we have to do. We have to insert 5 element. Fine, we have to insert 5 element in the same manner. What is the manner? P, Q, R, S, T. P, Q, R, S, and T. Now what you have to do? We have to pop out 4 items. It means we have to pop out these 4 items and insert into the queue. Fine. That is, first we have to pop out T, then we have to pop out S, when we have to pop out R, then we have to pop out Q. Fine. So these 4 items we are going to pop out from this stack. Then 2 elements, okay, then 2 elements are deleted from the queue. Now we have to delete these 2 elements. Why? Because in the queue, first in, first out. So now we have to insert T first. So T is here, then we have to pop out S and push into the stack. That is S. Now, which item we have to pop out? In the stack, we always pop out the topmost element, that is S. So S is the right answer. Very good, my dear students. Next. Now tell me, very important problem. Our relation R is defined as, we have a relation schema R with some of the attributes as has, status, city, S name, and where key is given to you. Now tell me, if R is decomposed into 2 relations R1 and R2, we have to find out which decomposition is lossless. And my dear students, keep in mind today at 5 p.m. you can attempt free mock test whose link is already present in this in the given video in the description. Fine. So at 5 p.m. it's a complete ditto paper which you are going to face in your, like, in the main exam. That question consists with 120 problems, 78 questions are from the technical, 42 questions are from the non-tech. So it's a just trial or demo of your original paper. Fine. So what is the answer? A. So Partha is saying A. Lucky, blur video. I think, Lucky, this side there is, I think connectivity is right. Please refresh your page. Lucky, tell me, the problem is for all of you or only to the Lucky? Yes, my dear students, tell me the right answer. Only Partha respond, that is A. Yes, my dear. Now keep in mind, my dear students, if I talk about, whenever we are talk about the decomposition, when we can say the decomposition is lossless, keep in mind, my dear students, first of all, whenever you are trying to union the attribute of the sub relations, that should be equivalent to the original relation attribute. Fine. That is the first condition. Moving towards the second condition, there must be a common attribute between the decomposition. Now see, here the common attribute is status. Here in this case the common attribute is city in the C option. In the D option the common attribute is again the status. But keep in mind, the second point is common attribute should be the key either of the subrelation 1 or the subrelation another. Now tell me, if I talk about in this relation, the given schema, if you are trying to decompose this relation into 2 subrelations, so S hash is the primary key. Fine. S hash is the primary key. So fine. In the C, in the option A, S hash and S hash, these are common attribute, and that is the key of even the R1 as well as the R2. Why? Because S hash is the key of R also. So what is the right answer? A is the right answer. Very good, Partha. Next, you can see here R1 union R2 must be equivalent to R. That means attribute. There should be a common attribute, and common attribute must be the key. That is the main concept to find out the decomposition is lossless or not. Now tell me, my dear student, question number 10. Consider a relation R, A, B, C, D with the following FD. Now the problem is you have to find out total number of keys. Can you just tell me total number of keys for this schema? Yes, is it clear all of you? Hello my dear students, is it clear for all of you? Say yes. Yes, Partha, is it fine? Fine, fine, great. Now tell me total number of key. Tell me total number of keys. Total number of keys. Hardly it's a problem of just 1 minute. So you have to find out total number of key by just seeing the FDs. You can find out that what is the key. What is the key of this relation? Can I say AB is a key? AB is the first key because AB determines C, C determines D. So AB is the key. Very good, my dear students. Partha, A is wrong. A is wrong. Yes. Now tell me, is there any attribute? My dear students, keep in mind this point. Is there any attribute either A or either B which is present on the right hand side of any FD? Yes, sir. Sir, A is present right hand side. So you can replace A by D. It means DB is also a key. DB is also a key. Fine, my dear students. Now tell me, either D or B. Yes, D is present on the right hand side again. So you can replace D by C. So CB is again a key. 3 key. Yes, Partha, right. Right. 3 is the right answer. So option B is the right answer. 3 is the total number of key present. Total number of keys 3. Fine, my dear students. Next. Very good. Very good. See, you can see here the closure of AB, DB, and CB determine all the attributes. So, my dear students, keep in mind now. Now, tell me, what is the binary equivalent of 100.625? What is the binary equivalent of 100.625? Please convert it fast.
Okay, so done. What is the answer here? Number system is important in digital electronics. You know, they may ask you some question from number system. ठीक है, कन्वर्जन के ऊपर क्वेश्चन आ सकता है, तो एक बार सारे कन्वर्जन्स को रिवाइज करना है एक बेस से दूसरे बेस में. ओके, सो किस किसने आंसर लिखा है? प्रणीत डी. एनी अदर? सो डेसिमल को बाइनरी में कन्वर्ट करना है ना, कैसे करते हैं? डेसिमल टू बाइनरी. डेसिमल टू एनी बेस कन्वर्जन के लिए क्या करते हैं? जो इंटीग्रल पार्ट है, जैसे यहां पे आपका 100 है, ठीक है, तो 100 आपका क्या है? इंटीग्रल पार्ट, और 0.625 ये आपका क्या है? फ्रैक्शनल पार्ट. तो दोनों को कन्वर्ट करना है सेपरेटली, ठीक है, बोथ टू बी कन्वर्टेड सेपरेटली. ठीक है, इसमें क्या करेंगे? सक्सेसिव डिवीजन यूज करेंगे, या फिर एक दूसरा ट्रिक होता है. देखो, डेसिमल को अगर बाइनरी में, डेसिमल इंटीजर को बाइनरी में कन्वर्ट करना है, सो 2 की पावर्स के टर्म्स में ब्रेक कर सकते हैं इसको. ठीक है, क्या लिख सकते हैं इसको? 100 को 2 की पावर में क्या क्या नंबर्स आते हैं जो 100 से नीचे होते हैं? ठीक है, उनमें लार्जेस्ट नंबर क्या है? 2 की पावर 6, 64. सो इसको लिख सकते हैं 64 प्लस 32. ठीक है, कितना हुआ? 96 और प्लस 4. ओके, 100 को ऐसे ब्रेक कर सकते हैं. सो 2 रेज़ टू द पावर 6 प्लस 2 रेज़ टू द पावर 5 और प्लस 2 रेज़ टू द पावर 2. ओके, नाउ जो पावर यहां पे प्रेजेंट है, यहां से स्टार्ट करेंगे. जो पावर प्रेजेंट है उनके नीचे 1, जो मिसिंग है उनके नीचे 0. राइट, सो 6 प्रेजेंट, सो 1, 5 प्रेजेंट, सो 1, देन 4 मिसिंग, 3 मिसिंग. Now 2 is present, Now 1 is missing, 0 is missing. So this will be the conversion of the this integral part into binary. Okay, ये वाला मेथड यूज कर सकते हैं. सो यहाँ पे कौन कौन से ऑप्शन है? 1100 100. सो एक तो यहाँ पे दिख रहा है हमें ये वाला, ठीक है, और दूसरा 1100 100, एक यहाँ पे. सो देयर आर टू ऑप्शंस जिनमें दोनों में सेम है इंटीग्रल पार्ट. नाउ फ्रैक्शनल पार्ट आर डिफरेंट. ओके, फ्रैक्शनल पार्ट डिफरेंट है. सो इसको कन्वर्ट करना है. 0.625 को कैसे कन्वर्ट करेंगे? 0.625 को 2 से सक्सेसिवली मल्टीप्लाई करेंगे. ओके, सो इक्वल टू कितना आएगा? 1250. सो 1.250. नाउ यहाँ पे क्या इंटीजर जनरेट हुआ? 1. इंटीजर 1 इज जनरेटेड, सो राइट इट हियर. नाउ फ्रैक्शनल पार्ट इज 2.25 into 2, so 0.50. So integer generated is 0. Okay, and then 0.5 is fraction into 2, so 1.0. So integer generated is 1. So इस तरीके से इसको लिखेंगे 101. So this number will be 0.101. Okay, उसके बाद यहाँ पे अब ये 0 आ चुका है फ्रैक्शनल पार्ट, आगे कुछ करने की रिक्वायरमेंट नहीं है. So D will be the right answer. Very good. बहुत सारे बच्चों ने कर दिया है. गुड. नाउ लेट अस सी नेक्स्ट क्वेश्चन and try to solve that. So what is the probability that a randomly selected month has 31 days? So tell me the answer, all of you. क्या आंसर होगा इसका प्रोबेबिलिटी का? प्रोबेबिलिटी से क्वेश्चन आपको मिल सकते हैं एग्जाम में, ठीक है. What is the probability that a randomly selected month has 31 days? So Lucky Kumar is answering. Any other student? जो भी प्रेजेंट है अपना अपना आंसर लिखें. क्वेश्चन आर नॉट क्लियर. What is the probability that a randomly selected month has 31 days? Okay, very good, very good. So students are answering C option. Very good. So randomly एक मंथ सेलेक्ट करना है, ठीक है ना. randomly हमें एक मंथ सेलेक्ट करना है. So what are the possibilities? There are 12 months, so there are 12 possible outcomes. Okay, so sample space में हमारे कितने पॉइंट्स होंगे? 12, right? And then फेवरेबल नंबर ऑफ केसेस. तो हम फेवरेबल नंबर ऑफ केस निकालना है. मतलब क्या करना है? क्या इवेंट है हमारी? मंथ हैज 31 days. So out of 12 months, how many months have 31 days? ठीक है, कितने ऐसे हैं जिसमें 31 दिन होते हैं? आप काउंट करके रख सकते हो. जनवरी से, जनवरी होता है, मार्च होता है, ठीक है, मई होता है, जुलाई होता है, अगस्त होता है, ठीक है, अक्टूबर होता है, दिसंबर होता है. सो हाउ मेनी मंथ्स? 7 months आर देयर जिनमें 31 डेज होते हैं. सो फेवरेबल नंबर ऑफ केसेस क्या हुआ? 7. एंड प्रोबेबिलिटी ऑफ इवेंट इज व्हाट? फेवरेबल नंबर ऑफ केसेस अपॉन टोटल नंबर ऑफ केसेस. सो 7/12 विल बी द राइट आंसर. Okay, now come to the next problem. So now let us see this problem. Read the question and try to solve, all of you. Read the question and provide me the answer. Anyone who got the answer, please write your answer in the chat box. क्वेश्चन को ध्यान से पढ़ो. प्रोबेबिलिटी इज इंपॉर्टेंट, प्रोबेबिलिटी से क्वेश्चन एग्जाम में आ सकता है, रिवाइज करके रखने हैं कंसेप्ट प्रोबेबिलिटी के, ठीक है। रूल ऑफ टोटल प्रोबेबिलिटी, बेस थ्योरम और जितने भी बेसिक कंसेप्ट होते हैं डायरेक्ट। ओके, सो देखो यहां पे मैं एक्सप्लेन कर रहा हूं इसको भी। A person uses his car 30% of the time, walks 30% of the time, and rides the bus 40% of the time when he goes to work. So when a person goes to work, क्या क्या ऑप्शंस हैं उसके पास, ठीक है। अगर कोई ऑफिस जाता है घर से, सो यहां पे 3 ऑप्शन मेंशन है, ठीक है, कि वो कार से जाता है, he goes by car, और he walks, और he goes by bus. Okay, so there are 3 म्यूचुअली एक्सक्लूसिव एंड कलेक्टिवली एग्जॉस्टिव इवेंट्स। इनमें से किसी एक ऑप्शन से ही जाएगा ना, अगर कार से जाएगा तो वॉक नहीं करेगा और बस से नहीं जाएगा। सो दीज 3 आर म्यूचुअली एक्सक्लूसिव, ठीक है, और तीनों ही ऑप्शन केवल दिए हुए हैं। सो कलेक्टिवली एग्जॉस्टिव मींस इन्हीं में से कोई ना कोई ऑप्शन चूज करेगा। नाउ 30% ऑफ द टाइम ही यूज कार, सो ऑन ए रैंडम डे he goes to office by car. What is the probability? It will be 30 upon 100. Okay, अगर परसेंटेज में दिया हुआ 30% टाइम वो कार से जाता है, तो किसी रैंडमली सेलेक्टेड डे वो कार से जाएगा, probability will be 30 upon 100. Okay, and then 30% of the time walks. So on a random day he will walk. Okay, what is the probability? It is also 30 upon 100. And he goes by bus. So 40% of the time he goes by bus. So on a random day he will go by bus. Probability will be what? 40 upon 100. Okay. Now if we go by any mean, there are 2 possibilities. He becomes late. He does not become late. Okay, not late. He walks, then he may become late, not late. If we go by bus, he may become late, yeah, not late. So in each situation, in each condition, whether he decide car or walk or bus, further there are 2 mutually exclusive situations, collectively exhaustive situations. Okay, now what is the data here? He is late 10% of the time when he walks. Okay, अगर वो वॉक करके जाता है, ठीक है, मतलब वॉक से जा रहा है, यहां पे हम आ गए, ठीक है ना, देन 10% ऑफ द टाइम क्या होता है, वो लेट होता है। तो अगर वो वॉक कर रहा है तो लेट होने की प्रोबेबिलिटी क्या होगी उस सिचुएशन में, ठीक है, इसको बोलेंगे 10 upon 100, राइट। ही इज लेट 3% ऑफ द टाइम व्हेन ही ड्राइव्स द कार। ओके, ड्राइव्स मींस कार को ड्राइव करता है। सो अगर वो कार डिसाइड कर चुका है जाने के लिए, तब लेट होने की प्रोबेबिलिटी क्या होगी रैंडम डे, 3 upon 100. ओके, एंड इफ ही इज गोइंग बाय बस, 7% ऑफ द टाइम ही टेक्स द बस। ओके, सो लेट होने की प्रोबेबिलिटी क्या है, ही इज लेट 7% ऑफ द टाइम व्हेन ही टेक्स बस, सो 7 upon 100. So this is the tree diagram of this problem which you can make easily. Okay, now क्वेश्चन क्या है, ठीक है, what is the probability he took the bus if he was late? So it is known to us that he was late. Suppose you met that person in office and you see he is late. Okay, but you don't know how he has come to office. Okay, आपको देखा, आपने ऑफिस में जाते हुए उसको आपने देखा लेट आ रहा है यार, ठीक है ना, बट वो आया कैसे है, वो व्हीकल तो ऑफिस के बाहर है, उसको नहीं, आपको नहीं पता है, ठीक है ना। सो आप प्रेडिक्ट करना चाहते हो, ठीक है, कि वो बस से आया है, क्या प्रोबेबिलिटी है कि वो बस से आया होगा, ठीक है। सो पी बस, प्रोबेबिलिटी ऑफ कमिंग विद बस अंडर द कंडीशन दैट ही इज लेट। सो दिस विल बी द सिंबॉलिक रिप्रेजेंटेशन। सो हमें पता है कि ये वाली इवेंट हो चुकी है, दिस लेट, वो लेट है ये हमें पता है, लेकिन वो आया कैसे है, इट मींस उसके पहले क्या हुआ है वो नहीं पता, उसकी प्रोबेबिलिटी हमें प्रेडिक्ट करनी है। तो बस से आया होगा, इसकी प्रोबेबिलिटी हमें निकालनी है। सो ये किसका प्रॉब्लम है, बेस थ्योरम का प्रॉब्लम है। ओके, अब इसको कैसे निकालेंगे, इक्वल टू बेस थ्योरम का फॉर्मूला लगाएंगे, तो प्रोबेबिलिटी ऑफ बस इंटरसेक्शन लेट अपॉन प्रोबेबिलिटी ऑफ बिकमिंग लेट, पी लेट। ओके, सो इक्वल टू पी बस इंटरसेक्शन लेट डिवाइडेड बाई अब पी लेट। पी लेट का मतलब क्या होता है, कब लेट, क्या प्रोबेबिलिटी है कि वो लेट होगा। अगर मैं इस ट्री डायग्राम में आपसे डायरेक्टली ये पूछता हूं कि क्या प्रोबेबिलिटी है कि वो किसी दिन ऑफिस जाएगा और लेट हो जाएगा, सो कार से जाएगा एंड लेट हो जाएगा, ये हो सकता है। सो पी कार इंटरसेक्शन लेट, प्लस वॉक करेगा एंड लेट हो जाएगा, सो पी वॉक इंटरसेक्शन लेट, प्लस बस से जाएगा एंड लेट हो जाएगा, सो पी बस इंटरसेक्शन लेट। ओके, ये फॉर्मूला लिखेंगे। अब इसमें वैल्यूज कैसे डालेंगे, यहां पे मल्टीप्लिकेशन रूल यूज करेंगे, ठीक है ना। बस एंड लेट मतलब बस लेगा तो बस लेने की प्रोबेबिलिटी क्या होगी, 40/100, सो वी विल राइट 40/100, and after that conditional probability that he will become late under the condition he has taken bus, so 7/100, so here 7/100 divided by, और उसके लेट होने की प्रोबेबिलिटी क्या होगी, this car intersection late, so car and late, so this into this. Okay, so directly you can write down the values now, 30/100 into 3/100 plus walk and late, so पहले walk करेगा तो 30/100 and उस कंडीशन में फिर वो लेट होगा, so into 10/100, multiplication rule we are using here. Okay, और plus बस एंड लेट। ओके, पहले हमने क्या लिखा है, ये 40 इंटू 7 अपॉन दिस, तो क्या बचा हमारे पास 40 इंटू कितना है, बस से 7/100। सो नाउ यू हैव टू कैलकुलेट दिस आंसर। ओके, सॉल्व कर लो, 100 मल्टीप्लाई होकर कैंसिल हो जाएंगे ऊपर नीचे और आपको आंसर मिल जाएगा। सो एनीवन हु गोट द फाइनल आंसर प्लीज राइट इन द चैट बॉक्स, सिंप्लीफाई करके कितना आंसर आ रहा है जल्दी बताओ। बेस थ्योरम के ऊपर बहुत ही सिंपल सा क्वेश्चन बन सकता है, ठीक है, आपको आइडिया होना चाहिए रूल ऑफ टोटल प्रोबेबिलिटी और बेस थ्योरम। सो प्रणीत इज गेटिंग 28/67, वेरी गुड प्रणीत, वेरी गुड, वेल डन। सो दिस सी इज द राइट आंसर हियर। ओके, नाउ कम टू द नेक्स्ट प्रॉब्लम। Nisu is also getting C answer, good. All of you please revise base theorem. Now come to next question. So read this question and try to find out the answer. Probability mass function is given to you, probability distribution is given to you, and you have to calculate E of this expectation. So you know expectation is also important topic. You should know how to compute expected value of a variable, random variable, and also expected value of a function of random variable. So anyone who got the answer, please tell me. जल्दी से कैलकुलेट करो एक्सपेक्टेड वैल्यू कैसे निकालते हैं किसी फंक्शन का। यस, सो देखो यहां पे एक फॉर्मूला आपको बता देता हूं। कोई भी रैंडम वेरिएबल का पीएम, ये डिस्क्रीट रैंडम वेरिएबल है जिसका प्रोबेबिलिटी मास फंक्शन में गिवन है पीएमएफ, ठीक है। इस पी एक्स इक्वल टू एक्स को हम एफ एक्स भी बोल देते हैं, ठीक है। क्या बोलेंगे इसको, एफ एक्स से भी रिप्रेजेंट कर सकते हैं। दिस इज एफ एक्स, ओके, प्रोबेबिलिटी दैट एक्स इक्वल टू एक्स, इट एफ एक्स। सो ई ऑफ एक्स, एक्सपेक्टेशन ऑफ एक्स इक्वल टू क्या फॉर्मूला होता है ई ऑफ एक्स का, समीशन ऑफ एक्स एफ एक्स। ये तो हमारे पास फॉर्मूला होता है किसका, एक्सपेक्टेड वैल्यू का। लेकिन यहां पे एक्स की जगह एक्स का कोई फंक्शन है। सो सपोज वी हैव ए फंक्शन जी एक्स, किसी रैंडम वेरिएबल का कोई फंक्शन है, ठीक है, और हमें निकालना है उसका एक्सपेक्टेड वैल्यू या मीन। एक्सपेक्टेड वैल्यू का मतलब मीन। सो इक्वल टू समीशन ऑफ जी स्मॉल एक्स और इनटू एफ एक्स। ओके, सो इक्वल टू समीशन ऑफ, अब यहां पे जी एक्स कितना हो जाएगा, ये वाला 2x + 1 का होल स्क्वायर, सो 2x + 1 होल स्क्वायर और इनटू एफ एक्स, राइट। अब इसमें आप वैल्यूज पुट करोगे, ठीक है, और समीशन करोगे। तो x को हमने सबसे पहले -3 रखना है, यहाँ पे -3 इंटू 2 कितना हुआ, -6 + 1 -5 का स्क्वायर 25, और इंटू में fx कितना है यहाँ पे 1/6 प्लस, ठीक है। सिमिलरली x = 6 रखेंगे, और उसके बाद यहाँ पे fx की वैल्यू 1/2 रखेंगे, फिर x = 9 रखेंगे, और तीनों टर्म को ऐड कर देंगे। बताइए कितना आंसर आ रहा है? एनीवन हु गेटिंग द आंसर प्लीज टेल मी। सिंपल कंसेप्ट है, कैलकुलेशन करना है छोटा सा। लकी इज गेटिंग डी आंसर। एनी अदर स्टूडेंट? प्रणीत? तो कंसेप्ट क्लियर है आपको? एक्सपेक्टेड वैल्यू और थोड़ा सा ना स्टैंडर्ड डेविएशन और वेरिएंस का भी फॉर्मूला याद कर लेना। बहुत स्मॉल वैल्यूज को दे सकते हैं, ठीक है, उसके बारे में भी कुछ क्वेश्चन आ सकता है, स्टैंडर्ड डेविएशन और वेरिएंस, ठीक है। और नॉर्मल पीडीएफ आपको आना चाहिए, पीडीएफ के बारे में, पीएमएफ के बारे में, राइट। सो 209 विल बी द आंसर। चेक योर आंसर। ओके, 209 एक बार कंफर्म कर लेना कैलकुलेशन। Now let us see this problem from digital electronics. The minimi SOP is, so digital में सिंपल बूलियन अलजेब्रा से क्वेश्चन मिल सकता है, कोई भी एक्सप्रेशन को मिनिमाइज करने के ऊपर क्वेश्चन मिल सकता है, या केमैप के ऊपर कोई सिंपल क्वेश्चन मिल सकता है, राइट। या फिर जितने भी हमारे डिजिटल सर्किट्स हैं उनके ऊपर कोई बेसिक क्वेश्चन बना सकते हैं, मल्टीप्लेक्सर के ऊपर, ठीक है, कोई सिंपल सा काउंटर का कंसेप्ट, फ्लिप फ्लॉप की कोई कैरेक्टरिस्टिक इक्वेशन पूछ ली, ठीक है ना। तो थोड़ा थोड़ा आइडिया आपको सब चीजों का रखना है। So please solve this problem and tell the answer in the chat box. The minimi SOP is, anyone who got the answer to this question, tell me. ओके, सो देखो इसमें क्या करेंगे, ये जो आपका डिजिटल का क्वेश्चन है, इसमें सिंप्लीफिकेशन करने के लिए आपको एसओपी में चाहिए तो ग्रुपिंग को वंस करेंगे। अब यहां पे अगर हम वंस की ग्रुपिंग करते हैं तो मैक्सिमम ग्रुप क्या बन सकता है? एक तो ये क्वाड बन सकता है आपका, ठीक है, और एक ये आपका क्वाड बन सकता है, ठीक है। नाउ दिस वन इज रिमेनिंग, सो दिस कैन बी मेड एज ए पेयर, यहां पे पेयर बना सकते हैं। अब देखो इसमें बच्चा गलती क्या करेंगे, ठीक है, एक ही मिस्टेक होने के चांस हैं कि कुछ स्टूडेंट्स इसको भी ले लेंगे, वो ऐसे ये वाला ग्रुप भी ले लेंगे, लेकिन ये जो रेड वाला है ये रिक्वायर्ड नहीं है, ये नहीं लेना है आपको, यहाँ पे ये रिडंडेंट ग्रुप का काम करेगा, ठीक है, बिकॉज ये दोनों वन को कवर करने के लिए इसको लेना जरूरी है, ठीक है, और इन दोनों वन को कवर करने के लिए ये भी लेना जरूरी है। अगर हमने ये दोनों क्वाड ले लिए तो ये चारों कवर हो गए वन, ठीक है, तो एक्स्ट्रा ये लेने की हमें रिक्वायरमेंट नहीं है, ठीक है। सो देयर विल बी ओनली 3 टर्म्स, राइट। एग्जाम में वो आपको 4 टर्म्स भी ऑप्शन में दे सकते हैं, ये वाली टर्म भी ऑप्शन में दे सकते हैं, बट वो आपको चूज नहीं करना है, ओके। सो ये आप मिनिमाइज करेंगे, कॉमन कोड कितना आएगा यहाँ पे 0 0 कॉमन है तो सी बार और यहां से ए बार, ठीक है, तो ए बार सी बार इसको बोलेंगे हम। उसके बाद ये जो हमारा क्वाड बन रहा है आमने सामने, तो इनमें कॉमन कितना है, इधर ये 1 कॉमन है, मतलब सी कॉमन है इधर से, और इधर से कॉमन क्या है 0, सो बी बार, ओके। एंड देन वी हैव ए पेयर, दिस पेयर, सो इसमें कॉमन कोड क्या है 1 0, सो मतलब सी डी बार, और इधर से कॉमन कितना है 1, मतलब ए, सो ए सी डी बार। सो ये तीनों टर्म को सम करेंगे, सो सी आंसर आपका मैच करेगा, ओके। नाउ लेट अस सी नेक्स्ट क्वेश्चन। So now let's solve this problem.
So yes, my dear students, the next problem, we assume the operations here the given are the infix is given and you have to convert this infix into the postfix. But keep in mind, my dear students, you have to note down all these stuff like plus, minus and star are left associative where power is right associative. Now tell me, do it fast. Yes, my dear students, please do it fast. What is the correct option? You have to convert this in fix into postfix. And my dear students, keep in mind, today at 5 p.m. you can go for the live mock test that is of 120 problems, which have 78 technical and 42 non-tech problem. Fine, my dear students. So keep in mind that point. And the link of that test is in the given description in this video, in the description. Fine. So now tell me, you are saying that A is the right option. Let's try it. So first of all, we know that power has the highest priority, and but the keep in mind, power is right associative. So we have power in this case D power E power F, but it is right associative. It means you have to start from the right. So first E F power, then D and power. So this is the basic thing. Fine. Now what you have to do? Now the remaining part is A plus B star C minus something, and minus is this part. Fine. Now plus minus star are left associative. Keep in mind, but we know that star is higher priority. So first solve this one. So B C star minus something. Fine. And here we have A plus. Fine. One part is this one part is this one, and one part is this one. Now what you have to do? Again, left to right, it means A B C star plus. So A B C star plus, then minus something. Fine. So in this way, the A is the right option. A is the right option. Fine, my dear students. A is the right option. Very good. Next. Very good. So next problem is, now tell me, this is a very good problem. You have to consider the following schedule involving two transactions. We have transaction 1, we have transaction T2. If 2PL protocol is used, then what is the right option? What is the right option? Yes, my dear students. Do it fast. Today at 5 p.m. you can go for the live mock, which is free, and you can start your mock. The link of that mock is given in the description box at right 5 p.m. Fine. It consists with 120 problems, 78 technical and 42 non-tech. Now tell me the correct option for this one. You have to implement 2PL. We know that what is 2PL. In 2PL, in one phase you can just request for the lock, and in another phase you can just unlock. If you are trying to request for a lock in the unlocking phase, your request will be denied. And we know that 2PL always guaranteed conflict serializability, but we have the problem in 2PL, my dear students. One is it is not free from irrecoverability, deadlock, and starvation. So A, no, my dear students, what are you doing? Professor, no, that is wrong. A is wrong. Nisu, yes, D. D is the right answer. D is the right answer. See, my dear students, if you go with that, cycle is there. One directly cycle is here, write, here, read. One is now write Y. So D is the right answer. We are here. If we go with that precedence graph, how we can construct the precedence graph? T1 to T2 and T2 to T1, and it is non-serializable in nature, and a deadlock situation is there because T1 is requesting for T2, T2 is requesting for T1. Fine. So correct answer is D, my dear students, not C. Fine. So keep in mind these type of problems. These are very important problems. You may do some silly mistake. That is the case. Moving towards the next problem. The maximum number of edges in an undirected simple graph without cycle. Yes, tell me. So what is the correct answer? A n minus 1, B n n plus 1 by 2, C n n minus 1 by 2, D is n. No, my dear students, C, maximum number of edges in an undirected simple graph without cycle. if in a graph we don't have this cycle, it means that is a tree. And in tree, if we have n vertices, n minus 1 edges. So right answer is A. My dear students, right answer is A. Because a graph which is not contain the cycle, that graph is a tree. Fine, my dear students. So keep in mind, answer is A. Next. So don't do the silly mistake, okay? Please read the problem carefully. Now tell me, this is again very simple problem, hardly 20 seconds. Yes, 2PL is always serializable, but it may not free from irrecoverability, deadlock, and starvation. Tell me, my dear students, you have to match the following tables with the recurrence relation. P is binary search, Q is merge sort, then quick sort, and tower of Hanoi. These are the options. Please match the recurrence relation. Yes. A. Parveen is saying A. Nisu is A. All of A. Let's check it. Binary search. We know that binary search divide the array into two half, and then the next time for the next iteration we just go with the single half. That means T of n by 2 plus constant. So P is 4. Very good. P is 4. Now merge sort. Divide the array into two half with the help of merge procedure, and then apply iteratively the merge procedure on both the sub array. 2Tn minus 2 plus Cn. 3. So 4, 3. You can eliminate this one. This may be, but with the help of Q, you can eliminate this one and this one. So always try to go for the elimination method. Quick sort, 1, tower of Hanoi, 2 key power and time complexity. So you have to learn the time complexity also. Binary search, log n, merge sort, n log n, quick sort, best case n log n, worst case n square, tower of Hanoi, 2 key power n. So always keep in mind these time complexities also. Next. Very good, my dear students. Very good. Your preparation is up to the mark, my dear students. Now tell me the answer of this one. What is the right answer? A network address has subnet with mask 27. Keep in mind, the mask is 27. Which of the following address is a broadcast address? You have to find out the broadcast address of one of the resulting subnet. Now tell me this broadcast address. Yes, my dear students, do it fast. You have only 40 seconds. Very good, very good. B, no, B, Pawan, B is the wrong. You have to find out, my dear student, broadcast address for that particular subnet. And we know that in the broadcast, host bit are 1. Fine. How you can write 159? B, Nitish, no, B is the wrong answer, my dear. How you can write 159? Tell me in binary. See, my dear students, what is the mask? Mask is 27. Means 32 minus 27, which is going to be 5 bit. You have to decide with the 5 bit only, okay? So if you are trying to convert 159, that is 100, then 5 times 1. Here 5 is all the 5 bits are 1. That means it is a broadcast address. Fine, my dear students. So right answer is D, not B and not A. Why A? My dear students, you have to convert first. And yes, right mode 5 bits must be 1. Very good, Nitish. Very good. Moving towards the next problem. Simple. See, you can see here why A, B, and C are wrong. Why D is the correct answer. Why? Yes, Nisu Pawan. Very good, my dear. Very good. Yes, moving towards the next problem. Now tell me. Tell me, my dear students. Fast, do it fast. Even though these problems are very simple, but you have to face these type of problems in your upcoming exam, my dear students. Here in this video we are trying to cover almost each and every topic from the subject. So my dear students, please go with this video again and again. Yes, tell me, what is the highest normal form? These type of questions already asked in the previous papers in the NIC. So try to save maximum time in other questions. Sometimes the question may be lengthy but easy in nature. So my dear students, keep in mind, you have to save that time on those questions and try to give the time to these type of problems. Fine. Nisu is saying, Nisu, yes, tell me for 21 question number 21st, what is the right answer? Now tell me, first of all, what is the key? What is the key? What is the key for this problem? Pawan, wrong, 1NF. Tell me, what is the key? What is the key? XY. Yes, my dear students, XY is the key because XY closure is XY. Y determine W, XY determine G. So XY is the key. Now tell me, is there any partial dependency? What is the meaning of Y? The meaning of this is Y determine W and W determine Y. Fine. Is there any other key? No. Now tell me, what is the right answer? Very good, professor. What is the right answer? Is there any partial dependency? Yes. Proper subset of key determine non-prime attribute. Fine, my dear students. Proper subset determine non-prime attribute. That's why it is in 1NF. Y determine W is partial dependency. Very good, my dear students. Very good. So it is in 1NF. Now, yes, operating system problem. Tell me, what is the value of X? Very important problem.
Okay, so this is saying that the read-write head of the disk is at 100. So if the read-write head is at 100, just a second. Okay, thank you, sir. Okay, so let's say the read-write head is at track 100. Okay, after that the pending requests are, it is going to 43. After that it is going to, let's say X is here, and then after that it is going to 44. After that it is going to 203, and then it is going to 175, and it is saying that total disk scheduling seek is 473. So what will be the value of X? So we can see from 100 it is going to 43. So 100 minus 43, we will be taking mod because it is distance. So it will be always positive. Plus from 43 we are going to X. After that from X we are going to 44. After that, so we will again write it, we can write it as X minus 43. So for the sake of making this question easy, let's assume X was here. So after that, from 44 it is going to 203. So 203 minus 44 plus, then after that it is going to 203 minus 175. So these are the options, these are the formulas which will equate to 473, and if you put all the values in this, X will come out to be 158. So it is pretty easy, these type of questions. After that, Next is construct the following AVL tree.
Yes, my dear students, the next problem is construct the AVL tree. Consider the following AVL tree and now tell me how many rotations are required to delete 47 from the above AVL tree. So we have to delete the element 47, right? The element are 40, 24, 11, 31, 27, 35, 55 and 47. Now tell me, my dear students, how many rotations we have to require if we just delete the element 47 and then we have to convert the given tree into the AVL tree. Do it fast. Do it fast. And my dear students, keep in mind today at 5 p.m. you can attempt your free mock consist with 120 problems of the same pattern of NIC. 42 problems from the aptitude part and 78 from the technical part, and the link of that test is in the description. In this video descriptions you will get the link, so you can attempt your zero. Lucky, wrong my dear. If you just delete 47, then the height of right subtree is 1, whereas the height of left subtree is 3. 3 minus 1 is 2, and in the AVL tree you know that the balance factor must be -1, 0 or 1. Yes, Nisu, you are right. C is the right answer. Yes, C is the right answer. See, my dear students, how you can do this question. If you just delete 47, then this will be removed. Now, height, the 3 minus 1, balance factor is 2. Now, what you have to do? Why this balance factor? This balance factor is not due to this direction, left and then right. This is a problem of LR. Now, if we have the problem of LR, try to find, my dear student, first of all, you need to convert this LR problem into LL problem. So how to convert it into LL problem? Do a left shift. Fine, my dear students. Now, if you do a left shift, 40, then 31 is here, then 31 is here, then 24 and 11. Now 31 is 35, and now, and my dear students, keep in mind, whenever we have LR and LL problem, after doing one rotation, no need to find out the balance factor. Fine. Now what you have to do? This is LL problem now, and if LL problem, you have to do a right rotations. Now 31 is the root 40, 55, 24, 11 and 40 left, 35. So now the tree is balanced, so you required 2 rotations because it is LR problem. Very good, my dear students. So you required 2 rotation. Is it fine, my dear? 27, you can write 27 here, less than 31 but greater than 24. Rishabh, fine? Great. So 2 is the right answer. Next, my dear, you can see here, then here. That is the final output. Fine, my dear students. Now tell me, let T be a tree with m vertices of degree 1 and n other vertices. Keep in mind, please read the question carefully. Please read the question carefully. Now tell me.
Okay. So it is saying that let okay. So let the tree T be a tree. So it is given that it is a tree. So with m vertices of degree 1. So there are m vertices in the tree which are having degree 1. So there they will be maybe they are leaf nodes and something like that. After that, there are n other vertices and their degree is not given. So the sum of degrees of the vertices of degree greater than equal to 1. So it is asking what will be the total sum of degrees of these n vertices when they are greater than equal to 1. So what we can do is, simply you can do, first of all, total number of vertices in this are m plus n, because m vertices have degree 1 and other vertices have degree n. So it will be m plus n. Now if it is a tree and you have been given vertices v, what will be the number of edges? Number of edges will be always equal to n minus 1 or v minus 1, because tree is a acyclic graph and it is minimally connected graph. So for a tree, if you have n vertices, you will have n minus 1 edges. So total number of edges will be equal to this. And if you apply, this is the total number of edges, if you apply handshaking theorem, 2 into m plus n minus 1, which is equal to 2 into edges will be equal to sum of all degrees. Now if I want to find the sum of degrees, the sum of degrees of these elements, the m vertices which have degree 1, their sum will be always equal to m, because m into 1, plus degree sum of these vertices where degree is greater than 1, not equal to, greater than 1. So we have to find this thing. So if you put this in this, so it will be 2m minus m. Well, m will come here, 2m minus m will be m plus 2 into n minus 1. So 2m plus 2 into n minus 1. So D will be our correct answer. Next is, so the reference polynomial used to check a CRC scheme is given as x4 plus x cube plus 1, and the data sequence is given as this. What will be the actual bit string that will be transmitted towards the receiver? So what we do in the CRC scheme is, we will create a CRC which we will use, and by using the XOR gates, we will find a type of padding which will be done in order for so that the receiver can compute that in the end and it can get the actual message. Or if it will not, if the receiver is not able to compute the CRC correctly, it will indicate that there has been some noise in the channel or the data has been corrupted. So what we can do is, so first of all, x4 x cube plus 1. So x raised to power 4, so we will put 1 here. X raised to power 3, we will put 1 here. X raised to power 2 is not there. X raised to power 1 is not there. And x raised to power 0 is there, which is equal to 1. So this is the CRC, and the data given is 1 0 1 0 1 0 1 0 1 0. So 5 times 1 0 we have been given. Now first of all, we will do padding of, if the CRC is of length 5, we will do padding of 4 zeros. And now we will try to compute the AND in this question, sorry, XOR in this question. So what we will do, so first of all, if I put 1 1, the CRC here, if I do the XOR, 1 1 will give you 0, this will give you 1, this will give you 1, this will give you 0, this will give you again 0, and we will take this 0 down. Now we will start from the next occurring one. We will start from the next first one that is occurring in the output. So what we will do, 1 1 0 0 1 again, and 1 1 will give you 0, and again 1 1 will give you 0, again 0, again 0, and this will give you 1. So we will take 4 more symbols from the up, 1 0 1 1 1 0 1 0. Again, if I put the CRC here, so again these will be 0 0 0 and 1 1, and again after that we will take 3 zeros from the top. We are taking 3 zeros from the top. And if I put again 1 1 0 0 1, the CRC, when you apply the XOR, you will get 1 here, and you will take the 0 from the up. And now if you can see, if you put the CRC here, it will not be enough because there are only 2 bits here in the LSB. After that, there are no bits. So this is the computed CRC. So what we will do, we will take the data as it is. So 5 times 1 0. we will put the CRC with it, the computed CRC, and we will send it to the receiver. Now receiver will do what? This polynomial, this CRC scheme will be known to both sender and receiver. So if the data is not corrupted and you apply the XOR with this CRC on the data that we have sent, it will again in the end, it will give you the padding of 4 bits. And if the receiver is getting padding of 4 bits, 4 extra bits, then it will know that these remaining bits are the data and the data is not corrupted. If you are not able to get 4 zeros at the end, this means that data was corrupted in the when you were transmitting the data to the receiver. Okay, I hope you understood it. Okay. So next is a relation R is defined as if the definition of the relation is given as if X is not equal to Y. So it is saying that you have to check whether it is symmetric, reflexive, or transitive. So we will check all of these. So first let's say check symmetric. Now if 2 are 5, because 2 and 5 are not equal, if 2 are 5 is present, this means 5 or 2 will also be present. So it will be symmetric. Let's check about transitive. Now transitive says that if 2 are 5, if what is the property of transitive? If X or Y is present and Y or Z is present, then X or Z should also be present. So if I take 2 are 5 and 5 are 2, then by transitive property it is saying that 2 or 2 should also be present, but 2 or 2 will not be present in this because X should needs to be not equal to Y. So it is not transitive. If I check about reflexive, again reflexive, for reflexive you need to have self loops. So the elements should be 1 are 1, 2 are 2, or 3 are 2, 3 are 3, and so on. So these will not be present. So the relation will be symmetric only. So first is saying symmetric but not reflexive. It can be the answer, because there can be an answer which is more powerful than this, and that answer could be symmetric but not reflexive and also not transitive. So let's see if we have any type of answer there. Symmetric and transitive but not reflexive, again false. Not reflexive, not symmetric, again false. Equivalence relation, if you want to have equivalence relation, the relation needs to be symmetric, transitive, and your reflexive all. So the correct option will be option A. Consider a grammar with the following start symbol as A. Determine the first and follow of the respective. Follow of A respectively. We have to determine the follow and first. So let's compute first. So if we want to find the first of A, we have to see what A is making. So A is making BA. So we have to see first of B. First of B is nothing but first of CB dash and first of epsilon. So first of yes, B is making CB dash and epsilon. Now if I go to first of C, it is having plus AD comma ID. So only one terminal is there which is plus. So plus will be our in our first. After that, when you put epsilon back here, so B will be put epsilon and there will be self loop here. So only plus will be our. After that again, if you try to compute A, you will go into the self loop. So this is the first in our case. What about follow? If I want to find the follow, what follow signifies is that whenever let's say you have to find the follow of A, so it signifies that if you see all the strings that are made by A, what will be the element that is just after the string that is made by A. So if it is saying that S is equal to AB and A is equal to, let's say, A, B is equal to B, and S is making string AB as a whole. Now in this AB, you can see that A is making this A. So what is the exact element which is just after the string that is being made by A, which is equal to B? So how we can find the follow of A? Go to the right side, see the element where A is present. So A is present here. So first of all, A is the starting symbol, so dollar will be its follow. Now here if you see A is just going back to the, because there is no element after A. So we have to see when we go here, we have to see the first of the just next element. So there is no next element here. So we will just move back to the self loop here. So this means this A is not giving us anything. After that, where A is there? So we have A here. So to find the follow of A, just find the first of the next elements. So first of next elements is D. So dollar and D and plus. So I guess these are not present in the options. So options are correct. Options are false. None of the options matches it. Now it is saying left recursion. You have been given. Consider a following grammar. S is equal to AA, B, A is equal to AC, and SD, comma, epsilon. And it is saying what will be the equivalent grammar with no left recursion. So try to find it. Now see, what we will do here is we can make this as a single string. A is equal to AC, and if I substitute S, it will give me AAD and BD and epsilon. So this is the thing, and we have to remove the left recursion. So what we can do here is A will go to BD, A dash, and because of this epsilon, again A dash, the formula that we have seen in our class also. After that, A dash will simply go to CA dash and AD, A dash and epsilon. Okay. So next is, if a graph with n vertices is regular of degree r. Now if a graph with n vertices, so the graph has n vertices, the degree r, it is a regular graph. What do we mean by regular graph? Regular graph is a graph which will be having same degree on all the elements. So everyone will be having degree r. Then its complement graph is regular of degree what? So it is a pretty good question. So first of all, let's say you have a n degree graph, and if you write the degree sequence of that, so it is a regular graph. So r, 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 and r. Let's say these are some n elements. So before doing this question, let's just take some smaller example and see. So if I do this, so it is a graph with in which everyone is having 2 degrees. Now what is the maximum degree possible? Maximum degree possible here is, so the for this element A, maximum degree possible was 3. So if you take the complement of this graph, you will get just this, where everyone is having degree 1. So you are doing what? When you are taking the complement, you are subtracting the degree of any vertex from the maximum degree that is possible. So maximum degree here was, so if you see the degree sequence of this graph, it will be 2, 2, 2, 2. And the maximum degree possible in a K. So for let's say this is G graph, and K of 4, which will be a complete graph of 4 elements, it will have degree sequence of 3, 3, 3, 3. So complement is nothing but subtracting your graph from the complete graph. So if I do this, K4 minus G, it will give me 1, 1, 1, 1. So if we have a n element graph, So n elements are there. So the complete graph will be called as Kn, and the elements degree will be equal to n minus 1, n minus 1. Everyone will be having degree n minus 1, which is the maximum degree possible. If you subtract this graph from the graph that is given in our question, you will get every element will have degree n minus 1 minus r. So I guess the option is n minus r. B option will be our correct answer. Now let's move on to the next question. Which of the following statements are not are true? So first, it is not possible for the propositions P or Q and the negation of P or negation of Q to be both false. So let's see. It is saying P or Q. Let's say let's write it down as this way. So if I do this 0 0 0 1 1 0 and 1 1, and same here 0 0 0 1 1 0 1 1. So in this case it will be 0, but if P is 0, there is some cancel, just a second. Just a second. Okay. So again I have to draw. So 0 0 0 1 1 0 1 1, and in this case P bar and Q bar will have value 0 0 will change to 1 1, it will be 1 0, it will be 0 1, and it will be 0 0. So at 0 0 P plus Q will give you value 0, and at P bar plus Q bar it will give you value 1. This will give you value 1, 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 this will give you value 0, but this will again give you value 1. So there is no case possible when both of them are having equal, both of them are false. So there is no case possible which is true. It is possible for preposition this to be false. So if you solve this, the preposition given is P implication negation of this. So if I open this preposition, it will say P bar plus whatever is on the right side of the implication. P bar implies Q. If I again open this one, I will get P bar bar plus Q, which will give us P bar plus P plus Q. P bar plus P, which will always be equal to 1, and 1 plus Q will always be equal to 1. So it is possible for this proposition to be false is false. So only A is correct. So the correct option will be option A.
So now tell me, my dear students, what is the right answer for this one? Question number 31. What is the right answer? Every BCNF decomposition is dependency preserve, not dependency preserve, need be dependency preserve, need not be, and none of these. Now tell me, my dear students, here need not be. Please update it. Need not be. What is the right answer? So every BCNF decomposition, yes. What is the right answer? Need not be dependency preserve. It may be dependency preserve, it may not be dependency preserve. So keep in mind, my dear students, the correct answer is C. So because not dependency preserve, it means always it is not dependency preserve. No, it may be the chance that it may be dependency preserve, and in the some cases it is not possible to preserve that dependency. So keep in mind, my dear students, please go with the options very carefully, and C is the right answer. Next, tell me see the maximum number of super key for a relation R where E is the candidate key given to you. Now tell me, what is the total number or the maximum number of super key possible? Yes, my dear students, total number of super key possible. We already covered this type of problems in our module, so you know how to find out the total number of super key. Yes, my dear students, one more thing is, please keep in mind today at 5 p.m. you can go with your mock paper, and the link of the mock paper is in the description. Fine. You are saying 8, 8, 15, 4 and 16. So my dear students, can you just tell me total number of attribute? Total number of attribute is 4. Out of that, one attribute is key. So 2 key power 4 minus 1. What is 4? Total number of attribute. What is 1? Number of attribute in the candidate key. That is 1. That is going to be 2 key power 3, which is going to be 8. So what are these 8 super keys? See, E. E with F, E with G, E with H. Next E F G, E G H, E F H, and next is E F G H. So these are the 8. These are the 8 super key. Fine. So right answer is A. Next, my dear students. Now tell me. Yes, very important problem. Now tell me, a table has T1. These are the roll numbers associated with the marks, and you have to perform this query. And now tell me, what is the output of this statement? What is the output? Akash, Lucky, Pawan, Racer, Priyanka, Professor. Tell me, my dear students, what is the right answer? Very important problem. The twist of this problem is the concept of null. If you know the concept of null, then you will get the right answer. So Akash, wrong, my dear. That is not the right answer. 25. Very good, Siddhant. 25 is the right answer. Why 25? Can anybody tell me why the 25 is the right answer? See, my dear students, if you perform any arithmetic operations with the null, it is undefined, null. Why? The meaning of null is unknown or unexisted. You don't know what is the meaning of null. So keep in mind, whenever you are performing any aggregate operations, first it eliminate the null, and you have to update marks with 5, 10. That means 10 plus 5 is 15. This marks is going to be 25, and this marks is going to be 35. My dear students, keep in mind, but this is going to be deleted because here we have null. Null plus 5 is null, undefined. Yes, Professor, very good. Now you have to add them and find out and divide by 3, but not by 4. Keep in mind, you have to divide by 3, but not by 4, because you already eliminate this row. Fine, very good. If you go with that, that is the 75 divided by 3 is 25. So 25 is the right answer. Don't do silly mistake in these type of problems. If you know the concept of null, you can easily solve this problem. Otherwise, it's create a problem. Fine, my dear students, keep in mind, first remove the null concept, null cell, and then perform the operations. Very good. Next, my dear students, now tell me, yes. Now tell me, what is the right answer for this one? Pre-order traversal. You have to find out the pre-order traversal of given tree. What is the pre-order traversal? So my dear students, tell me fast, do it fast. Yes, Racer, very good. B. You are saying the pre-order is 1, 2, 4, 6, 3, 5, 7. What about others? Lucky, very good. B. Professor B is the right answer. Very good, my dear students. In the pre-order, what you have to do? First, you have to print the given current node, and then you have to first go with the left subtree, and then you have to visit the right subtree. So you are right now at the root, so print 1. Fine. Then you have to move on the left subtree, that is 2. Again, you are on the node 2. Then again, is there any left? Yes, 4. Again, is there any left? No. Go move on the right. 6, 3, 5, 7. B is the right answer. Very good. Very quick. Now tell me, my dear students, keep in mind this picture, and you have to find out the next case is you have to find out the post order of the tree. Now tell me, this is the tree, and you have to find out the post order. Tell me, what is the post order? What is the post order, my dear? And keep in mind, my dear students, at 5, as today at evening 5, you can attempt your mock, which is of ditto pattern that is you are going to face in the upcoming exam. Fine, my dear students. So at 5 o'clock, you can start your mock, and the link of that mock is given in the description box. So, my dear students, you can click on that link and you can go for the mock paper. Yes, my dear students, tell me the post order traversal. What is the post order traversal? Please write the sequence 6427531. Raise up. Very good. Very fast. Very good, my dear. So, see, if you want to go for the post order, in post order, what we have to do? You have to first complete the left subtree, then you have to complete the right subtree, and then you have to print the root. Fine. So, start with the left. Is there any left subtree? No. Is there any left subtree? No. Is there any right? Yes. You have to go with the 6. Then you have to print 4. Then you have to print 2. Then 1. Is there any one right subtree is remaining? Yes. So first of all, please try to cover the right subtree. Move on the 3 or of the node 3. Is there any left subtree? Yes. First cover the left subtree. For node 5, is there any left subtree? No. So print 7, 5, 3 and 1. 642 7531. 642 7531. Very good, professor. Very good, racer. Yes, hardly these are questions of 20 seconds. So you have to save the time in these type of problems. Very good, my dear students. So the right answer is 6427. 6427. Where is 6427 and 531? D is the right answer. Very good. Yes. Now, moving towards the COA problem, which are very simple. You have to just find out the number of bits in the tag field. Do it fast.
Okay. So it is saying that let a two-way set associative cache has 128 lines with a 16 words. The size of the cache word is 16 words. So someone is saying 5 bits. Okay, let's see. So 16 words, suppose the memory is 16-bit address. So when memory is 16-bit address, it will be divided into cache memory. So let's say that this part is divided into cache. So these are the extra tag bits. And this is the cache. So in this you will have the cache offset, word offset, which is 16 words. So 16 words will have 4 bits will be required for 16 words. 128 lines. 128 lines means 2 raised to power 7. So 2 raised to power 7 lines. This means 7 bits will be used. So 7 plus 4 is equal to 11, and 11, if you subtract its tag, will be equal to 5. Now, this is for direct associative memory. It is asking two-way set associative. So what we do in two-way set associative? In two-way set associative, what we do is set offset, or you can say number of sets, if you can say. So let's say number of sets will be equal to number of lines that we use in direct associative, and those lines will be further divided into 2 sets. So initially, if you see the normal, your how the memory will be oriented, so that this will be cache. It will have 16 words in each here, and you will have 128 lines. Now, while doing set associative, you will divide that into further. It is a two-way, so 2 sets will be. You will divide it into 2 sets. So if you are dividing 128 boxes into 2 sets, then you will have how many lines here? You will have 2 raised to power 7, so 2 raised to power 6, because 64 this side, 64 this side. This is how two-way set associative will behave, because you are dividing the 128 lines into 2 sets. So here p-value set associative will be 0 and 1, and here it will be 2 raised to power 6. So this is for direct associative. For normal, this is for direct set associative. After that, two-way set associative, 4 bits will be for. Similarly for your word, then 6 bits for the set, because if there are number of sets is equal to 2 raised to power 6, the set offset will be what? Log 2 raised to power 6. So 6 bits here, and the tag bit will be 6 bits. Option A will be our correct answer. Now 6 bits for tag, and total 16 bits in the memory. Now next is saying that we want to read a word of the memory address 357A. So write down 357A. 3 will be written in hexadecimal, 3 will be written here in binary in such a way. So 5 will be written as this, I guess. Yes. 7 will be written as this. A is nothing but 10. So 8, this. So first 6 bits are tagged. What is the binary decimal value of this? So it is 1248. 1248. So 12 and 13. So correct option will be option C. So if you have address as 357A, 13 will be your tag value in decimals. Okay. Next is main memory size is this 4 KB. Page size is 1 KB. So this means number of pages are 4. If number of pages are 4, how many frames will be there? Number of frames will also be equal to 4. And it is asking number of page faults in LRU. So let's see the requests. It is 482, 3283, 126 and 7. Let me validate it. 482, 3283, 1267. Yes. So now first of all, first 4 will be always false because they will always be miss. So 4823. Now we have to see least recently used. So what do we do in least recently used is, if there is a fault, you will see all the pages that are present in, and on the left side you will see the first occurrences of them, and you will replace the, keep in mind, last first occurrence. What I mean by last first occurrence, we'll see it. Let's see. So it is a hit. So 4823 is a hit. This is also hit. This is also hit. 4823. So all these are hits. Now when one comes, it will be a miss. So what you will replace? You will replace the last first occurrence. So first occurrence of 3 is here. First occurrence of 8 is here. First occurrence of 2 is here. And first occurrence of 4 is here. So out of these first occurrences, we will replace the last first occurrence. So if I replace the last first occurrence, I will replace 4. So if I replace 4, 1823, which will be a page fault. After that, 2 will be a hit. 1823, again page hit. After that, 6 and 7, both 6 and 7 will give us page faults because both are not present in the memory. So total number of page faults are 7 page faults will be there in the memory. So note it down. Next it is saying that do this same. In the next question, that 39th question, it is saying that do the same thing and tell what is the number of page faults in if you are using optimal merge pattern. Now what we do in optimal merge pattern, as in LRU we were seeing on the left side we were seeing the last first occurrence. In optimal merge pattern, in the right side, for the future, we will see the last first occurrence, because if you think about it, what it is saying that we will replace the page which will be used at last in the future. So the pages which will be used more which will be used in the near future will not be replaced. We will be replacing the pages which will be used far more ahead in the future. So let's see. 4823283127. So again, first 4 will be there, 48323. After that, these will be, so page fault, page fault, page fault, page fault. These will be hits till now. This. So again, when we replace 1, we will see that 2 is being used here. After that, nobody is being used. So apart from 2, you can replace anything. Let's say I replace 1. So I replace 3, sorry, 1284, and it will be page fault. Again, 2 will be a hit. Now 6 and 7, again both will be page fault, page fault. So in this case also, again 7 page faults will be there in the system. So the options for this are, in the optimal page replacement algorithm, it is 1, 2, none of the same as LRU. Yes, we have seen it is same as LRU. Next is, what is the range of decimal integers that is represented by n bit sign magnitude? So we are using the sign magnitude SM. So we know for SM, for normally unsigned numbers, if you have seen in digital, for unsigned numbers, what is the range? 0 to 2 raised to power n minus 1. If you have 3 bits, you will be able to represent decimal number up to 7. For signed magnitude, it is nothing but minus 2 raised to power n minus 1 up to 2 raised to power n minus 1 minus 1. For 2's complement, what is it? If anyone can tell me. For 2's complement, it is minus 2 raised to power n minus 1 2 raised to power n minus 1. I guess we have not this here. Yes. So the correct option for SM will be minus 2 raised to power n minus 1 to 2 raised to power n minus 1 minus 1. Option B. Next is, which of the following addressing mode operand is part of the instruction? So let's see. In register, in operand, we will have, let's say, in instruction, we will have an register address. In direct addressing mode, we will have a memory address. In direct addressing mode, we will have a memory address which will take us to the this address will take if you go in this, in the direct memory access, if you go to 2000, you will get the data. In this, if you go to 2000, it will give you the address of the data. So it is being used as a pointer. So all these are addresses. Operand is part of instruction in immediate addressing mode. So option A will be our correct answer. Okay, which of the following statements is incorrect? LLG grammar has to be CFG. Yes, correct. LLG grammar has to be unambiguous. Yes, if it is not unambiguous, it will not be passed by our parsers. LSG grammars that are not CFG are present. No, this is false. LLG grammars cannot have left recursion. Yes. So LSG cannot have left recursion because your parcel will go into the infinite loop. If you have left recursion, if you have left factoring, it may give you a wrong answer. And if it has ambiguity, parser will not be able to parse it. So again, third option is correct option. If NFA contains n states, then equivalent DFA minimized in the best case will take how many states? So it is a pretty good question. Let's say your NFA is this. For A, you are going here. For B, you are going here. For B, you are going here. And for A, you are coming here, and so on. Now in this NFA, there is no final state. This is a NFA, but there is no final state. So it will not accept any language. So it is not asking maximum Nishu. So yes, Nishu Kumar. It is not asking maximum. It is asking minimized case. What will be the number of states in DFA? So it is not accepting any string. If it is not accepting any string, the resulting DFA will be like this. It will have only dead state, no final state. It is also accepting nothing. So one state will be our final answer. Next is choose the correct statements. So we are comparing the powers. We know NFA and DFA has equal power, which is part of finite automata. Greater than that, we have DPDA, and greater than that, we have NPDA. So the options are power of DFA and NFA are same. Yes. Power of NFA, DFA different. No. Power of DPDA and NPDA are different. Yes. Power of DPDA and NPDA are same. No. So first and third are correct. So correct option will be option B. Yes. Which of the following is regular? Strings of 0 whose length is a perfect square over alphabet. So perfect square. So if you are trying to find perfect square, the power of 0 will be, when power of 0 is perfect square, the power will not be in AP. if the power is not in AP, we cannot find a loop which will be done by finite automata, because finite automata has finite memory. So if you are trying to run any language which is having infinite number of strings, there must be a pattern in that which you can apply using which you can use in order to make a DFA with the loops. But if you don't have a specific pattern, like in AP, after every iteration you will add D, 3D, 4D. So there is a pattern here. So this is used. Now in this we cannot make it AB, so it is not regular. Set a set of palindromes made of zeros and ones. Now palindromes, you need to count the number of zeros, and then you need to, so first you have to find the first half of the string, and then you have to find the next half of the string, and it should look like WWR. For this string matching, NPDA will be required. Not even DPDA will be able to do it, because it will not be able to find where the mid of our string is. Strings of odd numbers of zeros over alphabet 0. Yes, odd number of zeros will represented by 0 over 2 raised to power n plus 1. 2 raised to power n plus 1, and the DFA for that will be 0 will be accepted here, and this will be odd number of zeros. String of 0 whose length is prime number of the alphabet. Prime number, you cannot see a pattern in the prime numbers. Even if you see about prime numbers, anything, let's say a raised to power p, if p is a prime number, it is not even CFL. It is a very commonly known CSL language. Consider a following language where n is less than 1000 and m is greater than 1. So we are comparing an, B, M, C, N. So we are comparing A and C. Now comparisons are your finite automata will not be able to do comparisons. But one thing is, the comparisons, n is less than equal to 1000. So the comparisons are what? Comparisons are finite. So if comparisons are finite, finite automata will be able to do it, and m is not dependent on anyone. So m can be anything. So you can write it as an B star, or if m is greater than 1, you can write it as B plus Cn. So the DFA will be any number of A's less than 1000. So as it is less than 1000, it will be your finite. So finite comparisons can be made. After that, B star you can make normally in, because there is no comparison. So L is regular, not context free. Well, so L is regular. If L is regular, if a machine that is finite automata, let's say it is having some power, if you are giving that language to a machine which is having more power than finite automata, obviously it will be able to do it, because if finite automata is doing it, PDA will also be able to do it. So that is why if a language is regular, it will also be a context free language. So the correct option will be option C. Don't be in a hurry and mark that L is regular and not context free, because if L is regular, as well as it will be context free. Sometimes the option will be like L is regular, so you will mark it L is regular as well as L is context free. But anyways, these type of ambiguous options they will not give, but in case if they give, you should be prepared to answer them in that way.
So now next problem is related to the DBMS. Now tell me, my dear students, please read the statement A carefully and tell me what is the right answer. Please read the statement A carefully and tell me the right answer. Yes, these are a straightforward, simple problem, but here there is chance that you can do the silly mistakes. Now tell me what is the right answer. And my dear students, keep in mind, today at 5 p.m. you can go with the mock paper. The link of the mock paper is in the description box. You can click on that link and then you can perform your mock. So D, Nisu is saying D, if R is in 3NF, keep in mind, my dear students, to check the given relation is in 3NF, what you have to do? Tell me what you have to do. First of all, you have to check that should be in 2NF, and if in any FD, left hand side should be candidate key or right hand side should be prime attribute. Then we can say that the relation is in 3NF. But now, my dear students, please read the statement A carefully. Pawan is saying D, Siddhant is saying C, Siddhant, please read the... Yes, Nisu, you are right. But please read the statement A carefully. D. Yes, D is the right answer. Why, my dear student? It is saying that if R is in 3NF, it means a relation already in 3NF and every key is simple. It means if it is 3NF as well as why it is 3NF, because every key is simple. There is no concept to check the right hand side is prime or not. Fine, my dear students. So it gives me mandate that the relation is in 3NF as well as every key is simple. It means the relation always be in BCNF. But if, listen carefully, my dear student, the converse of this is if R is in BCNF, then R is in 3NF. That is right. But every key is simple. That may or may not be the right answer. Fine, my dear students. In the case of converse, this part, every key is simple, may or may not be the true. That's why, my dear students, D is the right answer. Fine. That is the twist of this problem given a relation is in 3NF. Now, moving towards the next problem. Now, tell me, if a relation... Yes, that is again a simple problem, but you may do some silly mistake. Now, tell me, if R is a relation with set of functional dependency, A determine B, B functionally determine C, and we are trying to decompose this relation R into R1 and R2, R1 having A and B, R2 having A and C. Then tell me the decomposition is lossless, dependency preserve, lossy, dependency preserve. What is the right answer? Do it fast, my dear students. Yes, very good. You are saying C, the decomposition is lossless and dependency preserve. Again, you are doing some silly mistake. Nisu is saying D, the decomposition is lossy and not dependency preserve. See, my dear students, what you are trying to do. Hey, my dear students, see, we have a relation R. We have a relation R with A, B, and C. Now you are trying to decompose this relation into AB and AC. Now, if AB is there, what is the FD? A determine B, and where A is the key. Fine. Now, in the case of AC, what is the key? A determine B, B determine C. It means A determine C is the FD and A is the key. It means, now tell me, is the decomposition is lossless or not? Common attribute? Yes. A is there. A is key? Yes. It is lossless. But now tell me, is it dependency preserve? Is it dependency preserve? A determine B? Yes. But how you get B determine C? No. There is no way to get or preserve the dependency B determine C. Fine, my dear students. It is lossless, but not dependency preserve. So no one tell me the right answer, only Nisu, that is A. A is the right answer. So my dear students, these are simple problems, but don't do the silly mistake, okay? Fine. Next. Now tell me, at a particular time, the value of counting semaphore is 10. It will become 7 after how many operations? C. Please go with the one by one options and check the value of semaphore when it should be 7. If initially it is 10. Do it fast.
Okay, so the value of counting semaphore given is 10. So if the counting semaphore value is 10 and it will become 7 after some time. So it means there were total 3 extra down operations. There can be n. If n is the value of up operations, then there were up operations, then there were n minus 1, n minus 3, down operations, extra n plus 3 down operations. So there were plus 3 down operations. So if you say I have 0 up operations and 3 down operations, then also your value will become 7 because you will decrease the value of semaphore by 3. 3V operations, no. 13V, 10V, no. If you do 13V, the value will become 23. 23 minus 10 will be equal to 13. After that 5 and 2. So again the value will become 13. After that 10V. If you do 10V, so minus 10 plus 13, sorry, 10V operations. So 10 plus 10 minus 13, which will equal to 7. So you are doing 10 up operations and 13 down operations. So if you find the sum of these, it will be 3 down operations in total, because 10 up and 10 down will give you 1 minus 1 into 10 times will give you 0. So there will be overall 3 down operations, and if there are 3 down operations, your value will go from 10 to 7. Next is
See, my dear students, it's an operating system deadlock problem and very beautiful problem. See, listen carefully. Please read out the problem carefully. Consider M process. We have sharing N resources. Total number of processes are M. Total number of resources are N. Now, see, the maximum need of each process does not exceed N. That is the first point. That is the first constraint. And the second is sum of all their maximum need. Please keep in mind, maximum need is always less than M plus N. And what is M and N? M are number of processes, N are number of resources. Now tell me which of the following is true. You have 30 seconds. Please tell me the right answer. Now, how you can solve these type of problems? You have to take some some problems or some number M, number N, and then you have to go with the problem and then find out is deadlock occur, deadlock may occur, deadlock has to occur, or we have some data which is missing. Tell me, my dear students, do it fast. Very simple problem. It is cover all the logics, all the concept of deadlock. Yes, Pawan, Nisu, Racer, Professor. Akash is saying A, deadlock never occur. Very good, Akash. Very good. Now tell me, Akash, why is it so? Why is it so? Nisu, very good. Very good. See, my dear students, you can take some dummy data here. Suppose we have 4 processors, and total number of resources are 6. Find the maximum need of each process does not exceed N. This is my M, this is N. But it is saying that the sum of all their maximum need is 4 plus 6, 10. So 10 is the maximum need of all the processes. Fine. And how many number of resources we have? 6. Fine. Now tell me, if we have M processes, process P1, process P2, process P3, and process P4, and total number of resources are 6, maximum doesn't. And my dear students, suppose that the maximum need is 6. Fine. So 6 here, P1 required 6, then remaining 2, 1 and 1. That is the case. That may be a case. Fine, my dear students. So the maximum need is 10. Suppose always less than 10. It is saying that less than 10. So we have to take 1 here only. 6, 1, 1 and 1, 1. That may be the worst case scenario. Now, but the point is the maximum need of each process does not exceed N. What is N? 6. Does not exceed 6. That is again a good point. Fine. Now tell me, how many number of resources you have? 6. Now, if you have 6 resources, why not you can just complete these 3 processes first. Then whatever they just have the resources, they release the resources and give it to P1. Fine. So in this way, deadlock never occurred. Keep in mind, my dear students, deadlock never occur in this case. Very good. Very good, Akash, Nisu, Siddhant, Pawan. Very good. All of you are right. So for these type of problems, you just take some dummy data and try to solve. Fine. Now, my dear students, tell me, you have to again match the following: data link layer, physical layer, presentation layer, and network layer. Tell me the right answer. And keep in mind, my dear students, at 5 p.m. you can go for the live mock paper, and the link of that mock paper is in the description. You just click on that link and check your performance. And if you have any doubt, you can reach to YourPedia team at any point of time. Fine, my dear students. B. Nisu is saying B, Siddhant is B, Manit is B. Very good, my dear student. B is the right answer. B is the right answer. Very good. These are the functionality of each layer. You know very well. Fine. Next. Now tell me, in class B network, determine the number of subnet we can have with the subnet masks. In the class B, subnet mask is given. You have to find out the total number of subnet. Yes, my dear students, tell me the right answer. What you have to do? Do it fast. Just convert 240 into binary. D is the right answer. Very good. Very quick. On. Very good. 6. Nisu, no. You have to subtract -2 also. Keep in mind, my dear students, we cannot assign those IPs to a host. Fine, or subnet. So 14 is the right answer. You are skipping -2. Fine, Nisu? Yes, 2 ki power 4, then -2. Siddhant is right, Pawan is right, and Nisu is right. Nisu, not 16, but 14. You have to subtract -2 also. Fine. How you can write 240? How you can write 240? 4 times 0, 4 times 1, that is 1, 1, 1, 1, 0, 0, 0, 0. Then again 8 times 0. Fine. Now these ones are going to be considered as number of subnet, and the remaining zeros are host in each subnet. So we have 4 bits, 4 ones. It means 2 ki power 4, but you have to subtract 2. That is going to be 14. So 14 is the right answer, not the 16. Don't do this type of silly mistake. Fine. Next, my dear students, tell me the time complexity. Tell me the time complexity of this problem. Do it fast. For I equal to 1, I less than equal to root n, I plus plus, and it is nested in the nature that for j equal to 1, j less than equal to n, j plus plus. Tell me the time complexity. Do it fast. C is the right answer, my dear students. C is the right answer because for every I, j is executing n times. For every I, j is executing n times. And how many times of I executing? Root n. So n ki power 1 into n ki power 1 by 2, which is going to be n ki power 3 by 2. So C is the right answer. Very good. But always keep in mind, my dear students, you have to check how it is going to be incremented. Okay. Next. Which of the following propositional statement is or are tautology? Very good problem. Tell me which of the following are tautology. Do it fast. Do it fast. Yes, C is the right answer. Professor Siddhant, Pawan, Nisu, Akash, Rishabh. Very good. Shruti, very good. Very good, my dear students. Do it fast. Do it fast. Which of the following propositional statement is tautology? And if you like the session, please hit the like button. What is the right answer? Which of the following is the tautology?
Okay. So in this, let's see this is the second one. Let's see this one. This is much easier. So P implies Q. Implication P bar, implication Q bar. First of all, let's solve these two. So if you solve these two, you will get P bar plus Q, because implication opens as if A implies B, it is equal to A bar plus B. Implication P bar bar will be equal to P plus Q bar. If you come here, then you will get, again, if I apply the implication, I will get P bar plus Q whole bar implication P plus Q bar. If I solve this whole bar, it will give us P Q bar plus P plus Q bar. Now if I take Q bar P common, I will get 1 plus q bar, which will be equal to plus q bar, which will equal to p plus q bar. So now after this, we cannot reduce it. So this is not a tautology for sure. Let's see the first one. Okay. So the first one is P implication R, Q implication R implies again P plus Q implies R. I can write it as P plus Q implies R, which can be further written as P plus Q bar plus R. So this can be written as P bar Q bar plus R. So I am simplifying it on the way. So P plus Q bar plus R. Now this will be open to, we will open it as P bar plus R dot Q bar plus R implies P bar Q bar plus R. After that, when you solve this, discrete maths is in syllabus. They have asked the question in previous years also. And in the previous exam, they didn't mention discrete maths and theory of computation as the subject, but still they asked some part of it. So we have covered it. After that, implication, again, when you try to solve it, you will put plus here and you will put a whole this complement here. And when you apply De Morgan's law, you will get P plus R plus Q bar plus R plus P bar Q bar plus R. After that, when you solve it, you will get P plus R bar plus Q plus R bar plus P bar Q bar plus R. Now here, if you see R plus R bar, you can reduce it to 1. And 1 plus anything in Boolean will give you 1. So it is always a tautology. So only 1 is tautology. After that, next question. Which of the following is an integration testing technique? So integration testing techniques are of 3 types, 4 types in fact. First is bang bang, then we have top down, then we have bottom up, and then we have fourth type, which is combination of bottom up and top down. So we have sandwich. So there are, all of these will be our answer. So correct option will be all of the above. The longest software life cycle phase is, so longest life cycle phase will always be operation and maintenance. It is performed at the end and it will continue for a much larger period of time as compared to other cycles. Now we have, you have been given an SDT and it is saying that what is the translation of x, 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 y, z, z using the SDT. So first of all, by using this tree, we will try to make 4x, y, z, z. Now every time I make an s, from s, I can make 2x and I can make one w, and w will give again z. Now we have 2x and 1z, again 2x and 1z more required. So I can make it with like this, and in the end s will go to y. So we have x, 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 y, z, z. So our string is completed. So if I go and traverse it, first of all, here s of y is completed. So s of y is completed, so we will print 2. After that, here w of sz is completed, so we will print 3. Then here s is equal to x ww. All the SDTs are at the end of the your production. So this means whenever the production is completed, then only we will print this 3. So now we have printed 1, 2. After that, s is equal to xxy is done. So 1 will be printed. Again we will come back. W is equal to sz will be, so 3 will be printed, and again at the end s is equal to, so 2, 3, 1, 3, 1. So the correct option will be option C. Yes, option C will be our correct option. Okay.
Now consider a max heap. We are given some list of element, and now what we have to do? Given is a heap, max heap, and if we insert 35, what is the resultant new heap? Tell me, my dear student, what is the resultant max heap? Given a max heap having the element 40, 30, 20, 10, 15, 16, 17, 8, and 4. Now tell me, if you insert 35, what is the right answer? So in max heap, we know that root is always the maximum to their child. So 40, then 30, then 20, 10, 15, 16, 17, 8, and 4. Now if we want to insert element 35, that is left of 15, but if we want to construct it as a max heap, you have to swap, that is 35 will be here, 15 is here. Fine. Next, again compare with the root is smaller, then perform the swap operations. So the final answer is 40, 35, 20, 10, 30, 16, 17, 8, 4, and 15. So what is the right answer? 40, 35 will be the next. So option A and C we can eliminate. So 40, 35, 20, 10, and then 30. So I think option B is the right answer. Keep in mind option B. Fine, my dear students. Next, move on the next problem. Option B is the right answer. Now, tell me, what is the right answer? See, my dear students, here, if you can perform, what is f of n and g of, so first answer is f of n plus g of n is order of n cube. So n square plus n cube. In the case of plus, we have to do it the maximum. So maximum of n square plus n cube is n cube. So big O of n cube. Next, f of n dot g of n is order of n ki power 4. So f of n square into, but in the case of multiplications, we have to do the multiplications as it is. But in the case of plus, we have to find out the maximum. Then g of n is n cube, which is going to be n ki power 5. So it must be big of n ki power 5, that is less than equal to n ki power 5, but it is says n ki power 4, which is wrong. Now h of n dot g of n, what is h of n? N ki power 4. What is g of n? N ki power cube, which is at least must be n ki power 7. So this is the right. So which of the following is incorrect? Only 2. So there is no such options, none of these. So answer is 2 is the wrong. First and 3 are right. Keep in mind. Fine. First and 3 are right, but it is saying that incorrect. Now tell me, my dear students, how many minimum spanning tree can be found from the following graph? Do it fast. How many minimum spanning tree? Here you may perform the silly mistake. You may do the silly mistake. So please do it carefully. You have to take the minimum edges, and then you have to go with the next minimum edges. Now tell me how many minimum spanning trees possible. And my dear students, keep in mind today at 5 p.m. you can go with your live mock paper, okay? And the link of that paper is in the description box. Tell me total number of D4. No, my dear students. Tell me total number of spanning tree possible. Total number of spanning tree possible. Yes, total number of spanning tree. C. No. C is not the right answer. No, 3 is not possible. See, my dear students, what is the first spanning tree? A to F, F to B, B to D, and D to C. These must be present. 1, 1, 1, and 1. Now, A is covered, F is covered, B is covered, D is covered, and C is covered. The remaining part is the edge E. So, how we can cover edge E? One path is this one. And the next path is one is this one and one is this one. Here 2 and 2. So these are the two possible cases. Fine, my dear students. So only two. Two is the right answer, not three. Can you just tell me how we can go with the three? No, there is no such option. Okay. So always keep in mind, my dear students, only two. Two is the right answer. Very good, Nisu. Very good. So don't do the silly mistake in these type of problems, my dear. Moving towards the next. See, you can see here the two minimum spanning tree. Now, tell me the output of this type of problem. Relational algebra. Tell me the type. Tell me the correct answer of this type of problem. What will be the result of the following relational algebra? Project A comma B, and then you have to select C equal to 10 from the relation R. Nishu is saying A, Panit is saying A. Very good, very good. So first it is trying to select the records having C equal to 10. But whenever it is going to select C equal to 10, the row which is having C value or C attribute has 10, in the output of this nested query, keep in mind, in the output of this nested query, it reflects all the attribute, and from that you are going to project only A and B. It means it prints the column A and B from the relation R when C is equals to 10. So B is the wrong answer because there is no such information related to A and B. And again, D is the incorrect because it is also showing C column. Fine, keep in mind. So this is the wrong answer. So A is the right one. Very good, my dear students. Now tell me again, you have to find out the highest normal form. What is the highest normal form? First of all, you have to find out the what is the key for this relation. What is the key? What is the key? Please write in the chat box what is the key. A, D, E. Very good. Very good. A, B. B is not the right answer, my dear. So, Professor, you are talking about this problem or the previous one? Yes, Tejasvi, A, D, E. Very good, my dear. Now tell me what is the highest normal form? 1NF. Very good, my dear students, because A, D is the key. So A determine B is the partial dependency. That's why 1NF is the right answer. Very good, very good. Now tell me, my dear students, if the data rate of ring, it means it is talking about ring topology. And do you know that in the ring topology, what is the distance? Distance is equivalent to circumference. Fine. So if the data rate of ring is 20 Mbps, signal propagation speed is 200, then number of bits that can be placed on the channel. Very simple problem. Now tell me what is the right answer. Tell me the right answer. What is the right answer, my dear students? Tell me. Yes, Shruti, Pawan, Siddhant, Teresa, Pani, Tejasvi, Professor Nisu. Tell me the right answer. Not A. You are doing some silly mistake. I think it's 20,000 bits. Not A. See, my dear students. See the answer. You can see here. We know that in the token ring L, what is the length? Length, we have to circulate the message unless it is not going back, the token is not coming back. Fine. That's why whenever you are going for this formula, you can get 20,000 bits. Very simple problem. Now again, in IPv4 addressing, classful address is replaced with, even though token ring is not important, keep in mind, my dear students, but yes, they may ask the problem, but that is not important because now the token ring we are not going to use in the token ring in the recent scenarios. So now tell me, in IPv4 address, classful address is replaced with subnet, classful, and classless. What is the right answer? We know that because there is a problem in the classful addresses, wastage of the IPs. That's why we can go with classless addressing. That's why A is the right option. Moving towards the next problem. Very good, my dear students. Again, TLB problem, very important problem. These type of problems you may face where you have just put the formulas and solve the numerical. Now find out the values. What is the average access time?
Okay. So we have a TLB we have been given. Number of entries in TLB is 16. Associative search time of TLB is 10. So C is given as 10. And memory access time is 50. And TLB hit ratio is given as this. So what TLB does is, whenever we have a request, if it is found in TLB, you will just go and access the memory. If it is not found in the memory, you will go to the page table and you will access it. So if there is a hit, you will have C time, which is of TLB, plus 1 memory access to fetch it. And if there is a miss, so you have searched the C, it was a miss, plus 1 memory access to search the page table, because page table is present in the memory, and then 1 memory access again to get the page. So x plus x into C plus m plus 1 minus x into C plus 2m. If you put this formula, you will get 65 nanoseconds as your average access time. If you put here, you will get 65 access time. So important is just this formula and how it comes. You have to have the understanding of this. Next is 32-bit machine execute instruction. The following steps are carried out: fetch, code, execute, and store. So this means there are 4 steps. First of all, 4 steps are there. Each step takes 1 clock period. So let's say TP is equal to 1 clock period. We are not putting the value of clock right now, just 1 clock period. A new instruction is read and its execution begins with each new clock period if clock period is 20 nanoseconds. So if clock period is 20 nanoseconds, the time TP of pipeline will be equal to 20. Then there are 100 instructions, so N is given as 100. Then what is the speed up ratio over a non-pipeline processing system? Now in pipeline, we have 4 stages, each of 20 nanoseconds. In non-pipeline, the time will be equal to Tn, let's say non-pipeline time, which will be equal to number of stages into the time taken by each stage, or you can say sum of stage times, because we have divided this in a pipeline. If pipeline was not there, the total time would have been 20 plus 20 plus 20 plus 20 is equal to 80. So Tn is equal to 20, 80, and Tp is equal to 20, and N is equal to 100. Now speed up ratio is nothing but Et of non-pipeline over Et of pipeline. So Et of non-pipeline will be, if one instruction take 80, 100 will take 80 into 100. In Et of pipeline, we know that pipeline Et is K plus N minus 1 into Tp. So K is equal to 4, 4 minus 1 is 3, 3 plus 100 is equal to 103 into 20, which will come out to be 400 by 103. And if you calculate it, 400 divided by 103, 130 to be precise, will be equal to 3.88. So if you 400 divided by 103, if you perform the calculation, you will get 3.88. So these are simple simple operations that we are doing, but we need to understand how TP and TN are going to behave in these scenarios and what will be the your speed up factor in that case. So 3.88. In the solution, yeah, again 8,000, which is equal to, which is nothing but 80 into 100, and this is nothing but 103 into 20. So the thing that we use here. Next is cache organization is set associative. Again, okay. Main memory size not important here. Cache size is equal to 8 KB. Now each cache size is 8 KB. So let's say that this is the cache size 8 KB. It is divided into blocks and each block size is 64 bytes. So if block size is 64 bytes, 2 raised to power 6 bytes, I can write it as 2 raised to power 13 bytes. So it will give me 2 raised to power 7 lines. So there will be 2 raised to power 7 lines. We have done a similar kind of question. Now, number of blocks per set. In each set, we are putting 4 blocks. So these 2 raised to power 7 blocks, we are dividing into sets of 4. So this means how many lines will be here now? We will have 2 raised to power 5 because 4 lines will be here. 4 into 2 raised to power 5 will be equal to 2 raised to power 7. So set, if 2 raised to power 5 is the number of sets, this means that set of set will be equal to 5. So it is asking what is the word set and tag in the bits. So now memory sizes will be important. So okay, it is just asking number of bits in the set offset. So number of bits in the set offset will be 5. If it would have asked what will be the tag feed and something like that, then we would have required surely required the memory size, because now memory size is not required. We are just dividing the cache into number of blocks, and then those number of blocks into the sets of 4. So we have to find the set offset. It will be equal to 5. If they would have asked line offset would have been 7. Yes, correct, Nishu. Okay, what is the average waiting time of the jobs if preemptive shortest job algorithm is used? Okay, so let's say preemptive shortest job. So initially 0 is there and it comes, J1 comes at arrival time 0. So 0 to 1 we will have this. So 2 seconds remaining. At 1 J2 comes, which is having even less burst time, which is having more burst time. So again we will prefer J1 because there are only 2 processes now in the system. And if there are 2 processes and J1 is minimum, we will again give it 1 second more. Now J1 and now J3 comes into the system, but J1 and J3 are having same time. If J1 and J3 are having same time, we will give the preference to arrival time, which of the processes came first. So again J1 came first and we will complete it. So J1 is completed at 3. After that, all the system are in the system. Now there is no need to preempt because whatever the processes are present in the system. Whichever is lowest, just give the CPU to that process. So we will give 1 second to J2. It will be completed at 4. 4 to 6. It will be completed at 6, and it will be completed at 9. Now what it is asking, average waiting time. So first of all, we have to find the turnaround time. Now turnaround time is nothing but the amount of time for which the job was present in the CPU, whether it was in the system, whether it was executing, whether it was sitting idle or waiting for its turn. So it is nothing but completion time minus arrival time. So 3 minus 3 is 9 minus 1 is 8, 4 minus 2 is 2, 6 minus 3 is 3. Waiting time is the time for which job was waiting. Now this is the total time for which the job was sitting in the system. Out of this time, for some time it was computing. The remaining time it was the waiting time. So it is nothing but turnaround time minus burst time. So 3 minus 3 is 0, 8 minus 3 is 5, 2 minus 1 is 0, 2 minus 1 is 1, and 3 minus 2 is also 1. So it will be equal to, total waiting time will be equal to 7, and average waiting time will be equal to 7 by 4, which will come out to be 1.75. So the correct option will be option B with 1.75. Now let's move on to the next question. Consider the following grammar. Okay. Okay, these are the questions that are associated with. First, it is asking the language accepted by the grammar. Now let's see what the grammar is and what type of language can be accepted by it. So if you see S is equal to SAB, so it will make A raised to power N, B raised to power N. Number of A's will be equal to number of B's. After that, if you choose to go from S to A, you will come here. If you choose to go from S to B, you will come here. Now this is making nothing but A plus, this is making nothing but B plus. So it will make this or this. So you can see at least one A will be present here because it is A plus. It is not ending with epsilon, it is ending with a terminal A. So in this, number of A's will be greater than number of B's and the minimum difference can be 1. So A can be greater than 1, A can be greater than 2, or A can be greater than 3. In this, number of B's will be greater than A. So, and the difference will be greater than equal to 1. So if you see the options, it is saying, so option C will be your correct answer because it is saying AI, BJ and I minus J, which is the difference between number of A's and number of B's will be greater than equal to 1. Yes, either this will be true or this will be true because we have mod here. So I can be greater or J can be greater. This is the use of mod here. Next is the string which does not belong to the grammar. So let's say, so the string, okay, in this B are greater, in this A are greater, in this A are greater. So D will be our correct option because in D, number of A's will be equal to number of B's. From S, you will make ABS. From S, you will make AB. And then after this, even if you make A, even if you make B, or let's say you make A here, then again, it will have number of more A's. If you have B, then it will have number of more B's. So correct option will be option D. The advantage of better testing in software development is in. So one thing, in waterfall model, it is a basic model. You don't have any feedback in this. In iterative model, it is just form of waterfall model but with feedback. But one thing to notice is that feedback will not go to the first state. It will go till second state only. And third is prototyping, which is better for testing because we are testing our software, our product, and we are making a prototype. If customer does not like it, we are making another prototype, and this circle will go on until unless the customer is satisfied, and then we will move on towards the basic implementation of the software in bigger version. So B will be our correct answer. Testing phase effort is distribution up to 50%. Testing phase is up to 50% effort will be taken by testing phase. Remember this. Okay, next is waterfall model, evolutionary model, component model, spiral model. So one thing about spiral model, risk analysis will be there. Wherever there is a word risk, you will go for spiral model. So if, yes, C. So 4, we have C. After that, specification can be developed incrementally. Okay, so evolutionary model is made up of two models. It is a combination of two models, which is iterative and incremental model. So specifications can be developed incrementally and incrementally. So evolutionary model. So second will go to A. So 2A, 4C. I think B will be our correct option here because two options are only one option which is meeting our criteria. After that, waterfall model, inflexible partitioning of project into stages. Inflexible means the thing that I mentioned in the previous question also. There is no feedback, so there is very less flexibility in waterfall model. And similarly, the explicit recognition, requirements compromises are inevitable is in component based software model. So correct option will be option B. Next is which of the following grammars are in Chomsky normal form? Okay, so yes, so in Chomsky normal form, we have this type of production. So from variable you can go to two variables, or from variable you can go to one terminal. So in this we are going to epsilon, so it is false. In this we are going to terminal and variable, false. In B we are going to variable terminal, variable terminal. So B will be our correct option. So the options are A only, B only, both A and B. So it will be B only.
Now tell me the right answer. Which of the following statement is correct? TCP is a connection oriented. That is true. But so packet follow the same route from the sender to receiver. Is it true or false? TCP is connection oriented. That is true. But packet follow the same route from the sender to receiver. No, it is not talking about the route, but it only talking about the connection oriented. Okay. And next, HTTP packet follow the same route from the sender to receiver. No. Why? Because HTTP also based on TCP IP. That's why both are false. Fine, my dear students. Yes, HTTP uses TCP IP protocol. It is connection oriented, but it doesn't mean that they can follow the same path. Next. Which of the following scheduler selects a process from among the that are ready to execute, means ready to run state, and allocate CPU? Always keep in mind, we know that it is short-term scheduler. So C is the right answer. C is the right answer. Very basic, very simple problem. C is the right answer. Now tell me, what will be the output of the following problem? What is the output? See, my dear students, we have 1, 2, 3, 4, 5. 5 times plus. What is the right? D. D is error. Is it error or something else? Tell me. A plus 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 B. What is the right answer? Pawan, Nisu, Resab, what is the right answer? Compiler dependent. Very good. That's most of the time it gives the L value error. It is compiler dependent. D. D is the right answer. And the last one is, yes, stack data structure used in undo redo operations, web browsing history, recursion, all of the above. We know that these are the standard applications of stack data structure. So all of the above. Fine, my dear students. That is all about the 78 problems in which we discussed the algorithm, data structure, programming, OS, DBMS, COA, networking, then cloud computing, then other stuffs like discrete, TOC, compiler, digital. So we are trying to cover each and every problem by seeing, just go with the PYQs, previous year papers of NIC. So my dear students, now it's an announcement that you can go at 5 p.m. You can attempt your free mock paper, and the link of that paper is given in the description box. And my dear students, if you still have any doubt in any of the problem, you can mention in the chat box. We will contact you, or you can reach out to YourPedia team. And good luck, my dear students. Thank you so much.